Where does the input go? CTM is designed with a pretty flexible input mechanism which allows its core architecture to be applied across pretty much anything, as long as you can extract features from it. The raw input data would just need to be processed by a feature extractor module, and this could be a CNN for images or embedding layers for sequential data. After that, it'll pass through an attention layer to obtain QKV for the input, and this is where the chaos starts. In CTM, there are a certain number of neurons just like our brain, and this number can be set arbitrarily depending on your experiment size, which in the paper's case, they had between 128 to 4096 neurons for a model depending on the difficulty of the task they wanted it to solve. But for the sake of simplicity, let's just say there are 4 neurons for now. Another thing unique to CTM is that it has an internal clock, and that clock will have a base unit which we will refer to as a tick. Since an internal clock will always have to start, let's just say 4 ticks has already passed and we are on the 5th tick, also for the sake of simplicity. So that means the model has thought for 4 steps already. So this means the input attention, let's say an image, has already been looked at again for the 5th time. Since the input information has not changed so far, the same info will be sent to something called a synapse model. But before entering that model, the input attention will combine with the activations of the 4 neurons from tick 4. Here, you can interpret activation as a neuron's thought or a signal or something as simple as a number. This synapse model then looks at every neuron's thoughts at tick 4, compares the input attention with each of them, and generates something called pre-activations for every neuron,